Assalamualaikum and good day. I am Muhammad Azan bin Tamar Jaya from College Genius Azan, USIM. Today I'm going to present to you a review on clinoptilolite and its modification with different types of surfactants. Basically clinoptilolite is a natural zeolite and most of its application is on absorption application.
Basically, adsorption is a surface process that leads to transfer of a molecule from a fluid block to solid surface, which can occur due to physical forces or biochemical bonds. So, this concept has been used widely in adsorption technology because adsorption technology is a very quick, inexpensive, initial method, but is very highly effective. Well, uh, since for decades, the development in this field has been showing exponential growth in trends. So, besides that, why it's also attractive, it's very attractive is because it's very highly flexible that it can be integrated into a batch process as well as a continuous process, and there are many parameters that can be adjusted to fit the process objective. So this is a simple schematic showing how the adsorption process occurs. So basically, adsorption technologies is we use in tackling pollutants problem in water or wastewater. It involves the interaction between the adsorbent and adsorbate. As you can see in the figures, the the grey figures is adsorbent, and the blue and red spots adsorbates, which is in this case is the pollutants. So basically, some adsorbents for now are prepared from waste materials, most of them, and also we can obtain them from a natural environment such as zeolites. And for example, activated carbon can be prepared in 1 to 2 days, but it can perform pollutant removals in just short time, which is actually in within 15 to 130 minutes to completion. If we are able to optimize the adsorbent to a very high point, it may have a better performance. So, and adsorbate in the other hand is the compound that sticks or adheres to the solid surface, which is in this case the adsorbent. Okay, and the adsorbent is the pollutant. It may vary from dyes, pharmaceuticals, drugs, or nitrogenous compounds or solvents. Well, one of the adsorbents besides activated carbons is zeolite, and in this case is clinoptilolite. Clinoptilolite is actually one of the natural zeolites out there that we can obtain it in abundance, and it is a crystalline hydrated aluminum silicate that has a very porous structures up to microporous and microporous level, and it contains water and alkali and also alkaline earth in cations such as sodiums, magnesiums, barium, etc. So the special things about this clinoptilolite or other natural zeolite is they have a total net charge of negative, which you can also read my papers regarding why the total net charge is negative. Is so because it's negative, it naturally attracts cationic substance such as manganese ion, strontium, and cationic dyes. Well, the surfactant is in the other way. Surfactant is a surface active agents. It is an amphiphilic compound formed as a long chain molecule, having one segment as hydrophobic and the other as hydrophilic. It functions by reducing the free energy in the system by containing the bulk molecules of higher energy on the interface. As you can see on the figures that basically surfactants has two segments, the head and the tail. The head is the polar hydrophilic, which is water loving, and the tail is non-polar hydrophilics. So there are several types of surfactants. Okay, in this case, there are non-ionic surfactants, ionic surfactant, cationic surfactant, and zwitter ionic surfactants. Both of the surfactants have the same hydrophilic and hydrophobic segment, but what makes what makes them different is the head. For non-ionic surfactant, the head is non-ionic. For the ionic surfactants, which we can divide into anionic and cationic, they have either positive or negative charge. And the zwitter ionic surfactants, they have both charge on their head, which is positive and negative. Well, one of the modifications in kinoptolite to improve the performance is by it can be done in several methods. Okay, it includes surfactant impregnations, acid-base treatment, silver decorated, plasma activated, ion exchange, thermal and steam treatment. And on this slide, I will cover about the functionalizing kinoptolite with surfactants. So by adding the kinoptolite by adding the surfactants to the kinoptolite, we can have two types of phenomena. The first is the formation of monolayer, and the second one is the formation of bilayer. As you can see, right, with the formation of monolayer, we can see the tail is uh, head out away is is directed away from the kinoptolite, and the head, which is the hydrophilic part, will be attracted to the kinoptolite. When we increase the concentration of the surfactant, increase the concentration of the surfactant, we will have a bilayer formations in which the we can see that the surfactant attached to the kinoptolite is as well attached with another surfactant, another tails of the other surfactants. So if you have an ionic surfactant, you will have a negative charge kinoptolite. If you have a cationic surfactant, you have a positively charged kinoptolite. This this is what happened is this change the surface properties of the kinoptolite, which originally is negative in charge. So this is how we tackle different types of different spectrum of pollutants, which varies from anionic dyes, cationic dyes, or other organic compounds that we can that we would like to attract. So this is the recent application for surfactant modified kinoptolite. We can see that the exobate varies from dye, pharmaceutical waste, and some drugs, and even gases. As we can see that the first the first the first the first works here uh, done by Nodehi, it shows that the absorption capacity increased significantly by adding the hexadecyl trimethyl ammonium bromide as a surfactant to the kinoptolite. It increased from 16 to 200 milligram per gram. And the other interesting finding from all the work I list here is we can see that the absorption of uh, the sulfur dioxide gases increased as well significantly from uh, in terms of surface area and also volume when they add the surfactant polyoxypropylene and TiO2. And the other one is not only removal of dyes, the surfactant was also found to be an effective antibacterial agent that reduces the growth of gram positive and negatives. So all of these are the recent application I've uh, found in surfactant modified kinoptolite research. So what I conclude from my review that actually uh, most of the works recently in surfactant modification is about the pharmaceutical, textile, and heavy metals, and toxic gases and substance. Okay, but most of the work found later was to focus on a single system, which deals with single pollutant, when actually in the real world we are dealing with a multi-system or binary system that has more than single pollutants. And this condition or situation might have a significant impact on the actual absorption capacity of the modified kinetic. And some of the works increase the surface area of the current kinetic by ball milling into powder. However, this actually